Take a close look at this glass jar sitting on my counter. If you stepped into my kitchen right now, you might assume I was fermenting an unusual sourdough starter or preparing some dark, sweet syrup for a pancake breakfast. It's bubbling, it's breathing, and it carries a deep, rich aroma that seems to drift somewhere between warm gingerbread and freshly activated baker's yeast. But this cloudy brown liquid isn't meant for me. It's meant for the ground beneath our feet. Beside the jar is a simple scoop of white crystals, the same inexpensive kind you might pick up at a neighborhood pharmacy to ease tired muscles after a long day of physical work. Just 2 ingredients. The total cost? Less than $2. Yet while we stand here watching this humble mixture bubble, there's a shelf behind me crowded with bright, beautifully designed plastic bottles. They have bold labels, impressive numbers, and equally impressive prices. High NPK synthetic fertilizers, specialized root stimulants, and imported soil conditioners, all promising to solve nearly every garden problem with a single squeeze. I used to buy all of them. I remember walking through the garden center with that familiar knot of anxiety in my stomach, believing that if I spent another $50 or chose the bottle carrying the most professional-looking agronomic seal, my garden might finally resemble those perfect gardens in the magazines. But it never truly did. My plants would suddenly surge into an unnaturally vivid green, only to sink back into a tired, washed-out yellow a few weeks later. The soil became harder. Water began running across the surface as though it had struck concrete, and slowly, the earthworms vanished. Then came one of those quiet, discouraging evenings when I stood staring at a bed of miserable tomato plants that simply refused to grow. That was when I realized we had been looking in entirely the wrong direction. We've been taught to think of plants as leaves and flowers, the visible parts, the beautiful parts, the parts that put on a show. When trouble appears above ground, we reach for a chemical spray and soak the foliage. But a leaf is only a screen. It is showing us a film whose script was written days earlier, deep below the surface, inside the dark and silent world of the soil. So why won't an ordinary commercial garden center sell you what is bubbling inside this jar? Why does the multi-billion-dollar synthetic fertilizer industry keep these 2 simple grocery store aisles completely separate? Today, I'm going to bring them together. We're going to travel down into the soil food web, look back into the old traditions of organic homesteading, and explore the precise chemistry behind how a basic kitchen byproduct and an inexpensive pharmacy mineral can ignite a biological revolution beneath your feet in exactly 7 days. Are you ready to stop feeding the plant and start awakening the soil? Let's dive in. Part 1. The illusion of the green screen. Let's begin by changing the way we see the garden. Instead of imagining your garden bed as a collection of separate plants, picture it as an iceberg. The leaves, thick stems, swelling peppers, and opening rosebuds are only the visible tip. The real machinery, the engine determining the fate of every cell inside those plants, is buried in darkness, where neither you nor I can see it working. When a plant begins to fade, when its lower leaves lose their deep emerald color and drift toward a pale, unhealthy yellow, our first instinct is usually to feed it. We buy nitrogen. We pour on urea. We behave as though the plant were nothing more than a passive drinking straw, waiting for us to pump chemicals into it. But here is the quiet agronomic truth. Most of the time, when your plants sit there looking slow, weak, and unhappy, the soil is not actually empty of nutrients. The food is already present. It is trapped within soil particles, tightly bound to clay and mineral structures, beyond the reach of young, delicate root hairs. The pantry is full, but the door is locked, and the key has gone missing. So who holds that key? It isn't you, and it certainly isn't a chemical company. The key belongs to an invisible microscopic workforce that should be thriving beneath the surface. Healthy soil is not merely dirt. It is a living, breathing community. A single teaspoon of healthy garden soil can contain more microscopic organisms than there are human beings on Earth. Billions of bacteria, miles of fungal hyphae, tiny nematodes, and countless protozoa all live and work there. These are the laborers of the underground world. They break down organic matter. They loosen phosphorus and potassium that are tightly bound to clay. Then they deliver those nutrients to plant roots in water-soluble forms the plants can actually absorb. But when we repeatedly saturate the ground with synthetic chemical fertilizers, we bypass this entire workforce. We flood the soil with highly soluble salts. The plant receives a quick, almost addictive rush of nutrients, but the microbes are deprived of organic carbon. Their habitat breaks down, their populations collapse, and eventually they die. The soil then becomes compacted, hardening like dry concrete after rainfall. And what happens next? You have to buy another bottle. You become the permanent life support system for a growing medium that is slowly dying. How did we arrive here? How did we exchange a living, self-sustaining ecosystem for an endless cycle of expensive products packaged in plastic? Part 2. The $2 Symphony. This is where my $2 jar enters the story. The combination of plain, unsulfured Blackstrap molasses and Epsom salt is neither a modern scientific invention nor a piece of garden folklore. It is a biological symphony working across two very different timescales, addressing both the physical condition of the soil and the immediate metabolic needs of the plant. The first ingredient is Blackstrap molasses. I'm not talking about the light, refined syrup you might pour over pancakes. I mean the thick, dark, almost bitter substance that remains after the final boiling of sugarcane. During the late 1800s, sugarcane refineries often treated this material as a waste product. It was sold cheaply to nearby farmers, who soon discovered that this dark liquid was pure gold for their land. The second ingredient is Epsom salt, chemically known as magnesium sulfate. It was discovered in 1618 in the English town of Epsom, after a local farmer noticed that his cows refused to drink from a bitter spring rich in minerals. Since then, it has remained a familiar household and medicine cabinet staple for centuries. Each ingredient can be useful on its own. But when they are dissolved together in water, something beautifully cooperative begins to happen. Epsom salt supplies a rapid, bioavailable dose of magnesium and sulfur. These elements dissolve easily and can move into a plant's vascular system within hours. However, that same solubility creates a weakness. When Epsom salt is applied by itself, the minerals can wash away with the next rainfall, leaving the plant without lasting support. This is where molasses changes the entire situation. Molasses delivers a dense, sticky, carbon-rich feast that awakens dormant soil microbes. Those microbes begin multiplying rapidly, helping create stable soil aggregates that physically retain dissolved minerals and reduce the chance of them being washed away. The Epsom salt provides the spark. The molasses supplies the fuel and the anchor. Together, they cost less than $1 per gallon to prepare. Yet they create a two-part effect that no single synthetic fertilizer on Earth can reproduce. Part 3. Feeding the workforce, not the plant. To understand the real power of this mixture, we need to examine the sugar. And this is where many gardening tutorials on the internet get the story completely wrong. When you pour diluted molasses onto the soil, you are not feeding the plant. Your tomato plants cannot drink sugar. Their roots have no system for absorbing complex sucrose molecules, and their leaves have no need for carbohydrates applied from the outside. If you spray sugar water over healthy foliage, the stomata will not drink it. The liquid will remain on the surface, become sticky, and attract ants, aphids, and mold. The sugar is not intended for the plant. It is intended for the soil. Think of Blackstrap molasses as an enormous, high-energy carbohydrate banquet for soil microorganisms. Beneficial bacteria, yeasts, and fungi are constantly searching for carbon. Under ordinary conditions, they reproduce slowly, waiting for falling leaves, dying roots, or decomposing organic matter to provide their next meal. But when a diluted stream of molasses drenches the ground, it is like ringing a tremendous dinner bell in the darkness. Within hours, microbial populations around the root zone begin multiplying at a remarkable speed. Under ideal conditions, a single soil bacterium may divide every 20 minutes. Within 3 days, total microbial biomass can increase 5 to 10 times, forming a vigorous, living shield around the roots of the plant. A landmark study published in the Open Journal of Ecology confirmed that a single soil application of Blackstrap molasses can produce a dramatic increase in microbial activity lasting 4 to 5 weeks. As these billions of newly awakened organisms feed, They perform three extraordinary jobs. First, they release natural organic acids that act as chelating agents. These acids help dissolve minerals trapped within clay particles, unlocking phosphorus, iron, and potassium and converting them into forms plants can access. Second, they compete with disease-causing fungi and harmful soil bacteria for space and resources. By occupying the root zone, they help form a biological barrier that protects plants from root diseases. Third, when the temporary sugar supply runs out, many of these microbes die and decompose. Their tiny bodies release a slow, steady stream of organic nitrogen and minerals directly beside the root tips, precisely where the plant needs them most. You are not fertilizing the soil directly. You are laying out a banquet for the underground workforce that fertilizes it on your behalf. Part 4. The iron and magnesium of life. Now let's turn our attention to those white Epsom salt crystals. Epsom salt is magnesium sulfate, MgSO4 7H2O. And to understand why magnesium matters so deeply, we have to look at one of the foundations of life on Earth. Imagine placing a green leaf beneath an extremely powerful microscope. Move past the cell walls and focus on the chemical structure of a single chlorophyll molecule, the green pigment that allows a plant to capture sunlight and transform it into energy. What you would see is remarkable. The structure of chlorophyll is almost identical to that of hemoglobin, the molecule flowing through your veins and carrying oxygen to every cell in your body. They are like twin molecules built upon an ancient shared design. Only one central atom separates them. At the heart of hemoglobin in human blood sits an atom of iron. That iron helps give blood its red color and allows the molecule to bind with oxygen. At the center of chlorophyll in a plant sits an atom of magnesium. That magnesium helps make leaves green and allows them to capture light. Plants depend upon magnesium, in much the same way that we depend upon iron. When soil becomes deficient in magnesium, a problem that often appears in sandy soils that leach easily, acidic soils, or container gardens with limited soil volume, the plant runs into a wall. Its engine can no longer function properly. Without enough magnesium, the plant cannot produce chlorophyll. Its deep, rich green begins to disappear, and a very particular symptom develops: intervenal chlorosis. The tissue between the veins turns pale and sickly yellow, while the veins themselves remain sharply defined and dark green. At this point, the plant is essentially consuming itself. It breaks down magnesium stored in its older, lower leaves and transfers that magnesium toward the young growing tips, desperately trying to keep the engine running. When I apply Epsom salt, I am delivering that missing central atom directly to the plant's photosynthetic machinery. But it must be applied with restraint. As we are about to discover, soil chemistry depends on a delicate balance of ratios, and when it comes to magnesium, more is certainly not better. Part 5. The Science of Soil Breath. Have you ever asked yourself why compacted soil causes so much damage? The reason is simple. Soil needs open pore spaces just as much as it needs water and minerals. Healthy soil behaves like a porous sponge, ideally containing about 25% air and 25% water. When the ground is compressed by heavy foot traffic, excessive tilling, or chemical imbalance, those vital pore spaces collapse. The oxygen is forced out. Without oxygen, plant roots cannot carry out cellular respiration, the process they depend on to absorb water and nutrients. Buried beneath the surface, the roots begin to suffocate. But compaction is not only a physical problem, it is also chemical, and much of that chemistry centers on the relationship between two positively charged ions, calcium and magnesium. Both calcium and magnesium carry a double positive charge, K² and Mg². In clay soils, these charges help bind negatively charged clay particles together. But calcium and magnesium perform that job in very different ways. Calcium has a relatively small hydrated ionic radius. This allows it to draw clay particles together into loose, crumbly clusters. That process is known as flocculation. It creates the beautiful, aggregated, sponge-like structure that allows air to move into the soil and excess water to drain away. Magnesium, on the other hand, has a much larger hydrated ionic radius. It surrounds itself with a thick envelope of water molecules. When too much magnesium accumulates on clay particles, this watery barrier pushes those particles apart and causes them to disperse. The clay aggregates fall apart. The soil collapses into a dense, shapeless mass. Then, as it dries, it hardens like cement. This is why soil specialists, such as Brian Doherty, emphasize that healthy base saturation should remain within a strict balance, roughly 60 to 70% calcium and only 12 to 18% magnesium. In clay soil, the ratio of calcium to magnesium may need to reach as high as 7 to 1. So when we carelessly scatter pounds of Epsom salt across clay soil, we may actually increase the danger of severe compaction. We disperse the clay and close the pore spaces the soil needs in order to breathe. How, then, can we work within this delicate balance? How can we use this $2 mixture to bring life back into the soil without damaging its physical structure? Part 6. The Dark Side of the Miracle. We need to speak honestly about some of the myths circulating through the gardening community. You have probably encountered videos making promises such as, Epsom salt will triple your harvest, Epsom salt prevents blossom end rot, or pour molasses over everything and you'll never need fertilizer again. That version of the story is not merely scientifically incorrect. It can be dangerous for the garden. Let's begin by dismantling the largest myth. Epsom salt does not prevent blossom end rot in tomatoes or peppers. Blossom end rot develops when fruit tissue lacks calcium. This commonly happens because of uneven watering or root damage that prevents calcium from moving upward through the plant's transpiration stream. Epsom salt contains magnesium and sulfur. It contains no calcium at all. In fact, calcium and magnesium compete directly for entry into the plant's root system. If I add excessive magnesium to the soil, I can interfere with the plant's ability to absorb calcium. Putting Epsom salt into a tomato planting hole to cure blossom end rot is like pouring gasoline onto a fire. It makes the calcium shortage worse and intensifies the same rot I was attempting to prevent. The same principle of restraint applies to Blackstrap molasses. If too much molasses is applied, or if it is poured onto completely bare, lifeless soil with little organic matter, it can trigger an enormous microbial bloom that the soil cannot maintain. The bacteria rapidly consume the sugar. As their population explodes, they use up dissolved oxygen in the soil. Then the entire population may experience a sudden, destructive collapse. This boom and bust cycle can cause nitrogen immobilization. Starving microbes capture the available nitrogen in order to decompose their own dead cells, leaving the plants pale, stunted, and desperate for nutrients. There is another risk. If a plant is already suffering from active root rot, pouring sugar water around its roots may temporarily feed the disease-causing fungi before beneficial microbes have enough time to outcompete them. The infection may become worse. That is why this mixture should never be treated as a magic wand. It is a targeted biological tool. It requires accurate dilution, careful timing, and a clear understanding of the soil's existing condition. So how can we prepare it safely? What exact, field-tested recipe provides the greatest biological advantage while removing as much risk as possible? Part 7. Step-by-step alchemy. Let me walk you through the preparation of this mixture, because the small details, the water quality, the kind of molasses, and the dilution rate can determine whether the application succeeds or becomes nothing more than a wasted bottle. For 1 standard gallon, here is what you will need. Unsulfured Blackstrap molasses. This requirement is non-negotiable. The product must be Blackstrap molasses because it is the most mineral-rich extract remaining after sugarcane has been boiled repeatedly. It contains traces of calcium, iron, potassium, and magnesium. The label must also clearly say unsulfured. Some baking molasses contains preservatives such as sulfur dioxide, which are added to kill microorganisms. That is exactly the opposite of what we are trying to accomplish in the soil. Plain Epsom salt. Choose ordinary, inexpensive magnesium sulfate from the pharmacy or laundry aisle. Check the package carefully. It must not contain perfume, lavender essential oil, skin conditioners, or other additives. Those ingredients may be pleasant in a human bath, but they can quickly scorch plant tissue and interfere with the biology of the soil. Dechlorinated water. This is one of the most common places where the process fails. Most municipal tap water is treated with chlorine or chloramine because these chemicals kill bacteria. If I combine molasses with fresh chlorinated tap water, I may immediately kill the same microorganisms I am trying to nourish. Rainwater is the best choice when available. If tap water is the only option, leave it uncovered in an open container for 24 hours. During that time, the chlorine gas will naturally escape into the air, making the water safer for biological activity. Warm water for dissolving. Molasses is dense and sticky. If it is added directly to cold water, it may sink and collect at the bottom of the container. I begin by placing the molasses in a small amount of lukewarm water. Then I stir until the mixture becomes smooth, dark, and free of cloudy streaks. The golden dosing ratio. Add exactly 1 tablespoon of unsulfured blackstrap molasses and 1 tablespoon of plain Epsom salt to the container. Then add enough dechlorinated water to make 1 complete gallon. For a more advanced, 3-dimensional version, I can add 1 teaspoon of active dry baker's yeast to the warm molasses water before adding the Epsom salt. The yeast, Saccharomyces cerevisiae, feeds upon the sugars, multiplies, and releases natural plant hormones, such as auxins and cytokinins, which directly encourage root division. I allow this yeast-enhanced version to rest uncovered for 8 to 12 hours. This gives the yeast time to begin its metabolic activity before the solution is applied. How to apply? Pour the diluted mixture slowly onto the soil at the base of the plants. Use it as a soil drench and thoroughly soak the active root zone. 1 gallon of finished solution can treat approximately 12 to 20 mature plants, or as many as 30 young seedlings. Here is the crucial rule. Never splash the molasses solution onto the leaves. Sticky sugar left on the foliage can attract ants, aphids, and flying insects directly to the plant. Molasses belongs below the surface, in the darkness where the soil workforce lives. Finally, wait 30 minutes after applying the mixture, then water the area lightly with plain water. This second watering carries the dissolved minerals and sugars deeper into the root zone. It protects them from evaporation at the surface and delivers them toward the actively growing root tips. Part 8. Cultivating the self. As I watch this dark, sweet liquid sink into the dry ground and disappear beneath the surface, I cannot help thinking about the deeper lesson hidden inside this simple practice. We live in a culture obsessed with speed, immediate results, and anything that promises a quick fix. We are trained to judge everything by its surface appearance: the emerald lawn, the flawless rose bed, the perfectly formed fruit arranged on a supermarket shelf. We expect our gardens to perform whenever we demand it, and when they slow down, we search for a chemical solution that can force them back into production. But as every experienced grower eventually learns, a garden is a mirror. It reflects our relationship with time, it reveals our patience, and it exposes our willingness, or unwillingness, to care for the things that remain hidden from sight. When I shift my attention away from feeding the plant and toward feeding the soil, I practice a quiet form of humility. I acknowledge that I do not make the garden grow. I am simply the caretaker of an ancient and unimaginably complex web of life, one that had been feeding and renewing itself for hundreds of millions of years before human beings ever stepped onto the earth. And in my own life, how often have I treated a deeper problem as though it were nothing more than a pale, yellowing leaf? How often have I reached for a fast external stimulant to cover my exhaustion instead of looking toward my own roots, my rest, my relationships, and my connection with the earth? Awakening a tired garden is not about pouring on more chemicals. It is about rebuilding structure, supplying carbon, and allowing biology to carry out its slow and beautiful work. What areas of your own life have become compacted, heavy, and unable to breathe? And what might happen if, instead of demanding an instant miracle, you began feeding the living foundation of your daily habits with a little patience, a little attention, and a little time? Conclusion: the harvest that matters most. The transformation begins underground, hidden from sight, several days before you will notice a greener leaf or a stronger stem above the surface. By the third day, the microbial bloom is underway, with populations gathering and peaking around the roots. By the fifth day, the pale yellow tissue between the veins of the tomato leaves begins to deepen in color, gradually returning to a stable, healthy green as magnesium reactivates the chlorophyll engine. By the seventh day, the soil itself begins to look and feel different. The dry, crusted earth starts holding together. Its color deepens, and earthworms begin returning to places where they may have been absent for months. None of this is magic. It is simply biology returning to its natural and elegant design, because, at last, we chose to step aside and nourish the living system. A garden rewards timing, not price. It responds to biological intelligence, not chemical force. For less than $2, the jar sitting on my counter contains a key that no chemical patent can ever lock away. So the next time you walk through the aisles of your local store, stop for a moment in the baking section. Then pause again in the pharmacy aisle. Look beyond the brightly colored plastic bottles and their expensive promises. Remember that some of the most powerful solutions are also the simplest, the least costly, and the closest to the earth. Thank you for sharing this quiet and thoughtful afternoon with me here at Earthly Delights. If this journey into the hidden science of soil has awakened a new curiosity in your gardening heart, please subscribe, share this video with another plant lover, and become part of our growing community of caretakers. Step into your garden this weekend, feed the soil, watch the dark earth closely, and allow life to return. Until next time, keep cultivating your earth, and keep cultivating yourself. I'll see you in the next video.